Most people think of the Second World War as an industrial conflict defined by factories, research labs, and mass production. Tanks, aircraft carriers, radar arrays, and code-breaking machines dominate how the war is remembered. But that view quietly erases another reality that mattered just as much on the ground. For many soldiers, resistance fighters, and civilians drawn into combat, survival depended not on standardized equipment, but on whatever could be built, modified, or weaponized with their own hands. Industrial war created shortages as often as it produced abundance. Supply lines failed. Units were cut off. Occupied populations had no formal arsenals at all. And in those conditions, warfare often looked far less mechanized and far more improvised than popular history suggests. This is one of the most overlooked truths of the conflict. Some of the most effective weapons used in World War II were never meant to be weapons in the first place. They were bottles, socks, cleaning tins, farm tools, scrap metal, and household fuel. These improvised tools didn't just fill gaps, they reshaped tactics, influenced resistance doctrine, and revealed something essential about human adaptability under extreme pressure. If you value deep historical insight into survival and improvisation, subscribe to the Survival Record, because this is the kind of overlooked battlefield reality that rarely makes it into conventional narratives. When glass bottles filled with fuel became one of the most feared anti-armor tools of the war, the Molotov cocktail is often treated as a symbol rather than a serious weapon, but its battlefield role was practical, calculated, and devastatingly effective under the right conditions. Finnish soldiers facing Soviet armored columns during the Winter War and later phases of World War II relied heavily on fuel-filled glass bottles with improvised ignition systems. These were not crude desperation measures. They were engineered solutions to a specific tactical problem. Early anti-tank weapons were scarce, and many infantry units lacked the means to disable armor directly. But tanks of the period had vulnerable external components, engine vents, vision slits, and exposed air intakes. A burning fuel mixture poured into these areas could disable engines, blind crews, or force emergency evacuation. Finnish troops refined ignition methods, adding tar, chemical igniters, or cloth wicks designed to burn long enough to ensure contact before extinguishing. This tactic shaped later infantry doctrine regarding close assault against armor. The Molotov cocktail demonstrated that mechanical superiority could be countered with proximity, timing, and terrain awareness, principles that still inform modern urban anti-armor strategy. When a simple sock filled with explosives became a precision demolition tool, British forces developed what became known as the gammon bomb, but its core design reflected a remarkably simple principle. Flexible containment allows adaptable explosive force. Soldiers used cloth, often a sock, as the container, filling it with explosive material adjusted to the mission. More filler meant greater blast. Less filler meant controlled demolition. The importance of this design wasn't just portability. It allowed soldiers to tailor explosive yield on the spot, something factory-issued grenades could not offer. Troops used these devices against vehicles, fortified positions, and infrastructure. The flexibility mirrored modern modular demolition charges, but its origins were rooted in the logic of field improvisation. It also reflected a broader wartime lesson: standardized equipment is efficient, but adaptable equipment is survivable. When resistance fighters turned metal cleaning tins into fragmentation grenades. In occupied Poland, access to manufactured weapons was severely limited. The Polish Home Army responded by transforming everyday commercial packaging into explosive casings. One of the most notable examples was the Sidolówka, named after Seidel metal Polish containers used as the grenade body. These tins were packed with explosive material and scrap metal, creating fragmentation when detonated. Their value lay not only in lethality, but in concealability. They looked ordinary, could be transported without immediate suspicion, and were built with locally available materials. This approach became foundational in resistance warfare worldwide. weapon design that blends into civilian infrastructure. Modern insurgent doctrine still reflects this principle. Tools that hide in plain sight disrupt occupying forces far more effectively than visible stockpiles. When bamboo farming tools became last-ditch anti-invasion weapons. In late-war Japan, shortages of steel and industrial collapse forced widespread weapon improvisation. Civil defense units and militia formations trained with sharpened bamboo spears, tools originally designed for agriculture and fishing. While often dismissed as symbolic or ineffective, bamboo weapons reflected a strategic calculation rooted in geography and mass mobilization. Bamboo is strong, lightweight, and abundant. In close terrain, urban ruins, forests, narrow approaches, it could serve as a viable thrusting weapon. More importantly, it enabled rapid mass arming of civilians when no alternatives existed. The lesson was not technological but logistical. When supply chains collapse, the environment itself becomes the armory. When bundles of standard grenades became improvised anti-tank charges. Soviet soldiers facing German armor frequently combined multiple grenades into a single bundle to increase explosive force. Individually, many standard grenades lacked sufficient power to penetrate armored vehicles. Together, they could disable tracks, damage suspension, or rupture vulnerable structural points. The technique required extreme proximity and personal risk, but it demonstrated an important tactical insight. Cumulative explosive force can compensate for technological limitations. Later, shaped charge designs would formalize this principle scientifically, but its battlefield origins lay in simple bundling and timing. Improvisation, in this case, directly foreshadowed later anti-armor engineering. When guerrilla fighters built functioning firearms from plumbing materials. In the Philippines and other occupied regions, resistance fighters produced improvised firearms, often called pipe guns, constructed from basic metal tubing, springs, and simple firing mechanisms. These weapons were unreliable compared to factory arms, but they required minimal specialized tooling and could be built in dispersed workshops. Their strategic value was psychological and logistical. Even limited firearm capability allowed ambushes, sabotage protection, and symbolic resistance. The ability to manufacture weapons locally reduced dependence on supply drops and enabled sustained insurgency. This approach anticipated modern, decentralized weapons manufacturing. Production networks designed to survive disruption rather than maximize efficiency. When ordinary household containers became deadly booby traps. Across multiple theaters, soldiers and resistance fighters used everyday objects, tin cans, bottles, discarded containers, as triggers or housings for improvised explosive traps. These devices were rarely sophisticated, but their unpredictability made them powerful force multipliers. They slowed troop movement, forced constant vigilance, and consumed time and resources in clearing operations. The psychological burden of potential hidden threats altered behavior more effectively than many conventional weapons. Modern counterinsurgency doctrine still reflects this wartime lesson. Uncertainty is itself a weapon. When demolition charges were assembled from loose explosives and whatever held them together. In the Pacific Theater, United States Marines and other forces frequently assembled satchel charges from blocks of explosive material wrapped in tape, cloth, or bags. These were used against bunkers, fortifications, and entrenched positions where standard grenades lacked sufficient power. The key feature was modularity. Soldiers combined explosive units as needed, shaping blast intensity to the target. The concept mirrored earlier improvisations, but became increasingly standardized through repeated battlefield success. Improvised design, once proven reliable, often becomes formal doctrine. That pattern appears again and again in World War II field innovation. What these improvised weapons reveal about warfare that industrial history often misses. These examples share a common foundation: necessity forces adaptation, faster than any research program. Improvised weapons emerged not from theoretical design, but from immediate tactical problems. Armor without anti-tank guns, occupation without supply lines, fortifications without heavy artillery. They also reveal something deeper about survival under systemic stress. Industrial warfare tends to centralize power, factories, logistics networks, command structures. Improvisation decentralizes it. It transfers agency back to individuals and small units. In that sense, these weapon hacks were not just tools. They were expressions of autonomy in environments designed to eliminate it. Many modern military survival principles, redundancy, adaptability, decentralized production, trace directly to these wartime experiences. The story of World War II is not only the story of machines built in factories, it is also the story of tools built in basements, barns, forests, and occupied streets. Understanding these improvised weapons reminds us that warfare is never purely technological. It is human, adaptive, and shaped as much by scarcity as by abundance. Remembering these lesser-known realities matters because they reveal how people endure when systems fail, how ingenuity fills the gap between vulnerability and survival. If you value in-depth historical analysis that explores what most accounts leave out, subscribe to The Survival Record and share this video with others who believe history is worth understanding in full, not just in outline.